All right, in this screencast, we're going to finish up the lesson on combined gas laws with Dalton's law of partial pressures. So Dalton's law of partial pressure states, for a mixture of gases in a container, the total pressure exerted is the sum of the pressures that each gas would exert if it were alone. So in mathematical terms, we add up all of the individual pressures to get the total pressure. Okay, so that's Dalton's law of partial pressures. All right, so here's an example. It says 100.8 grams of O2 and 289.8 grams of N2 are pumped into a 6-liter scuba tank that's kept at 20 degrees Celsius. Find the partial pressures of each gas, and then find the total pressure in the tank. All right, so the first thing we need to do is we need to figure out our pressures individually of oxygen and nitrogen. Okay, so we're going to still be using our ideal gas law equation. So PV equals nRT. We're trying to isolate the pressure. Pressure is equal to nRT over the volume. Okay, so that's the equation that we're going to need to plug into. Now, oxygen and nitrogen are given in grams, not moles. So our first step is going to be to take our grams and convert it to moles. So for nitrogen, 289.8 grams of nitrogen, and let's convert that to moles. So we have, for every 1 mole of nitrogen, we have 28.02 grams of nitrogen. Okay, so when we do our math here, we end up with 10.34 moles of nitrogen. Let's do the same thing with oxygen. Let's find our grams of oxygen. So we have 100.8 grams of oxygen. And let's go ahead and convert that. So let's see, we have 32 grams of oxygen for every 1 mole of oxygen. Okay, and then you'll end up with 3.150 moles of oxygen. Okay, now we have our moles. Now we have everything we need to plug into our equation to find the pressure. So let's start with nitrogen. So for nitrogen, it is going to be our moles. So 10.34. R 0.0821, and then our temperature was 20 degrees. Don't forget to convert that to Kelvin. So 20 plus 273.15 will end up with 293.15. So 293.15 Kelvin. And that's going to be over the volume. The volume of our tank is 6 liters. So our pressure for nitrogen will be 41.5 atmospheres. All right, we're going to do the same thing for oxygen next. So we're going to need to take our moles of oxygen and plug it into our equation to get our pressure for oxygen. So let's go ahead and do that. So for oxygen, pressure is going to be equal to the number of moles our R value, and our temperature. We're going to use the same temperature because they're both in that scuba tank at the same temperature. And that's going to be over our volume, 6 liters. And we end up with a pressure of 12.6 atmospheres. So that answers the first part of our question here. The second part asks us to find the total pressure. So we just add them up. So P total is going to be equal to the sum of both pressures. So nitrogen was 41.5 atmospheres, and then oxygen was 12.6 atmospheres. So we add those together and we end up with 54.1 atmospheres.